Hello, today I'd like to introduce you to Erlang OTP servers. In this video, then I will be covering the advantages and disadvantages of using it, some common types, how it's used in the real world, and then at the end then I'll have an example of how I've implemented an Erlang OTP server, which uses a React database. To start off, an overview of what are OTP servers. The Open Telecom Platform servers. They're processes that manage the execution of related tasks in a fault-tolerant system, such as if you have a database system, then it handles putting things in, taking things out. They're designed to be robust and scalable, written in Erlang, using Erlang design principles. The key features are concurrency. They're lightweight, which is really good for creating a lot of processes and communication between servers. They're fault-tolerant because they use supervision trees, which are servers that watch over the other servers. They can be widely distributed, so if you have servers running in multiple locations, then that's totally fine, and you can hotcode swap, where you can update it without stopping the system. Different types are the gen server, which is your basic server functionality, gen events, which handle events, usually system interrupts or something. They usually work with the gen servers, and a gen state machine, where the most simple type is just an on or off state, such as a switch between the two. And supervisor servers, then they manage the other three types of servers. So gen servers, and they use common patterns for server processes such as API call functionality and have internal functions for handling synchronous calls, asynchronous calls, and state management, as well as process lifecycles. And then we have supervision trees. So these provide the structure for fault-tolerant systems. Because the supervisors start the OTP servers, they collect and report error messages and restart servers that crash. Then the advantages of using Erlang OTP servers are they have high fault tolerance with supervisor trees, efficient processes for massive concurrency, clear separation of types of functions, which makes the code easier to understand once you learn it, and it works very well with low latency. Disadvantages are it has a steep learning curve, cannot match the speed and efficiency of some languages such as C or C++, and it's less mainstream than a lot of other types of languages. How it's used is designed for telecom systems, but it can effectively be used for messaging systems, finance systems, or gaming systems. It's used by Amazon, WhatsApp, Cisco, Pepsi, Pinterest, and other big companies as well. Those are probably the ones you've heard of. So in conclusion, then it's a good basic framework for robust, concurrent, fast, and fault-tolerant systems. So despite the steep learning curve and limited use, the benefits make it a compelling choice. And then I have some examples of code that we are going to run with this gen server that I have set up right here, running in Windows Subsystem for Linux, a Rebar 3 shell project. This is the backend API code that the gen server will be accessing. This is the supervisor that will be running the gen server, and here's the gen server itself. So first we export all the API functions. These are the ways to start the server, stop the server. Then we have putting a package in and getting the location of that package. We have putting a location in and getting the latitude and longitude of that location, and a location request API. This is initializing the server. And then these calls are the synchronous functions, and the casts are the different types of asynchronous functions. Then we have getting info about the current state of the server, terminating it, changing the code within it, and then below there are just some unit tests that I've set up for it. So then to start off, then we will be calling the put package function, which is this right here. So we can put a package in, returns OK, so that put package function calls the gen server cast function down here, which asynchronously checks and makes sure that both the variables are there, and then calls the DB API for putting a package into the database, into the React database. So then once we've put it in, then we can use this, which does a call, which is a synchronous function, which returns location 1 when we put in package 1. Likewise, we can put in a location with a latitude and longitude, and we can get that latitude and longitude using this function right here. So then if we put in the package ID with a location request, then now that all that data is in, then the package ID should return the latitude and longitude. So that's a basic example of how a Gen server should work with a React database. And I hope that you've learned something today, and thank you for watching. You have a good day.